Hello there my friends, welcome to this video where I'm going to be taking you through the Cambridge International AS and A-Level Pure Mathematics paper for February-March 2020. So I'm going to be taking you through the questions, showing you the required solutions as well as the workings. So let's get started. So I'm now scrolling down to the first question. Here's question number 1. It goes, the function f is defined by f of x is equal to 1 over 3x plus 2 plus x squared for x is less than minus 1. Determine whether f is an increasing function, a decreasing function, or neither. Now, in order for you to be able to determine whether a function is increasing or decreasing, you need to first find the derivative of that function. So right here, we've got our function, and the function is f of x is equal to, and I'm going to write down 1 over 3x plus 2 in this way. So that will be 3x plus 2 to the power of minus 1, and that's plus x squared. So this is our function. Now, I'm going to find the derivative of the function. So that's f prime of x is equal to, I'll bring down the minus 1, so minus 1. Then I write down the derivative of 3x, and that's going to be 3. Then I write down the function 3x plus 2, so that's 3x plus 2 to the power of minus 1 minus 1, so that becomes minus 2. Now for the derivative of x squared, I get 2x here. I'll simplify, so f prime of x, the derivative is equal to minus 1 times 3, that's minus 3. And it's all divided by 3x plus 2 to the power of 2, and that's plus 2x. So what we have right here is the derivative of the function. Now, I would want you to look at this function, and I believe you can see that minus 3 is a negative number. 3x plus 2 for all values of x, even here they've given us that x is going to be less than minus 1. So for any value that x is going to take, since it's a squared term, then it's always going to be positive. Now, positive divided by a negative divided by a positive number, overly, that's going to give us a negative number. Okay, so this whole part here is going to be negative for all values of x. 2 times x that we have here, if you look, we have x is less than minus 1, so x is always going to be negative. So 2 times a negative number is also negative. So if we're adding 2 negative numbers, it means that in this case, f prime of x, or the derivative, is always going to be less than 0 for all values of x which are less than minus 1. So if the derivative is less than 0, this means that the function f is a decreasing function. So that's the answer here to question number 1. I'm now taking you to question number 2. So here's question number 2. It goes, the graph of y is equal to function of x is transformed to the graph y is equal to 1 plus f of a half of x. Describe 2 single transformations which have been combined to give the resulting transformation. Okay, so right here, we've got our function y is equal to 1 plus f of a half of x. There are 2 transformations going on here. This one is a stretch. This represents a stretch. you need to know that all transformations represented by the function f of ax from a function of x represent a stretch parallel to the x-axis, and the stretch factor is 1 over a. So this is a piece of information that you need to know. And then we also have this part, the 1, it represents a translation parallel to the y-axis. So that's a translation, because you need to know that the function f of x plus a, where a is a constant, represent a translation parallel to the y-axis. So 1 is being added to the function, so that means that it's a translation. So here's how you write down the solution. So you say the first transformation is a stretch parallel to the x-axis with the y-axis invariant, and then the stretch factor is 1 divided by a half, so that's 2. Then the second transformation you say is a translation in the direction of the y-axis by positive 1 unit. So in other words, the graph is going up by 1 unit. So that's the transformation here for number 2. So that's it for question number 2. We can now go on to the third question, number 3. Here's question number 3. The diagram shows part of the curve with the equation y is equal to x squared plus 1. The shaded region enclosed by the curve, the y-axis, and the line y is equal to 5 is rotated through 360 degrees about the y-axis. Find the volume obtained. So this is a volumes of revolution type of question. Now the formula that we are going to use goes the volume when the shape is rotated about the y-axis is equal to pi times the integral from the lower y limit to the upper y limit of x squared dy. So this is the formula that we're going to use. So here we're saying the volume obtained is going to come out as pi integral from 1 to 5 of x squared. Now for x squared, we can see that y is equal to x squared plus 1. So x squared is going to give us y minus 1. So here I'm now going to do the integration. So that's volume is equal to pi times the integral. The lower limit is 1 and the upper limit is 5. I'm integrating x squared, so I'll put y minus 1 here, and that's dy. Okay, so I'll continue. That's pi, and I'll open up a square bracket. So the integral of y is y squared over 2, and integrating minus 1, we get minus y. Our limits, we have 1 and 5. I'll substitute 5, so that's pi, and substituting 5, we get 5 squared over 2 minus 5, and that's minus, substituting 1, that's just 1 squared over 2, that's 1 over 2 minus 1. So this is definite integration. So this will give me 5 squared over 2 is 25 over 2, and that's minus 5. Then half minus 1 is minus a half. So minus and minus a half gives us plus half. 25 over 2 plus a half, that's 26 over 2. And 26 divided by 2 is 13. 13 minus 5 is 8. So the answer should come out as 8 pi. That's the final solution here. That's the volume of revolution according to what the question requires of us. Question 4. A curve has equation y is equal to x squared minus 2x minus 3. A point is moving along the curve in such a way that at P, the y coordinate is increasing at 4 units per second and the x coordinate is increasing at 6 units per second. Find the x coordinate of P. So here we have the equation of the curve. Thus y is equal to x squared minus 2x minus 3. We've also been given that the y coordinate is increasing at 4 units per second. So we can write that as dy by dt is equal to 4. And they've also given us that the x coordinate is increasing at 6 units per second. So that's dx by dt is equal to 6. So we can use the chain rule. That's dy by dx is equal to dy by dt divided by dx by dt. So here, dy by dx, we can find it, the derivative of y with respect to x. That's dy by dx here should give us x squared. If we derive it, we get 2x, and here we get minus 2. Remember, the derivative of a constant gives us 0. So in place of dy by dx, we have 2x minus 2. Then dy by dt is 4, and dx by dt is 6. Okay, so if I add to both sides, then we have 2x is equal to 4 over 6 plus 2, and that's 16 over 6. Then if we divide both sides by 2, then the 2's will cancel on the side, and divided by 2 means here we get 8. And 8 over 6 is 4 over 3 to lowest terms. So x comes out as 4 over 3. And this is the value, the x coordinate of P. X gives us 4 over 3. That's how we work this one out. Let's scroll down to question number 5. Question 5. Solve the equation tan theta plus 3 sine theta plus 2, all divided by tan theta minus 3 sine theta plus 1 is equal to 2 for 0 to 90 degrees. So the values of theta range from 0 degrees to 90 degrees. So this is what I'm going to do. I'll multiply both sides by the denominator. This means that we'll now be having tan theta plus 3 sine theta plus 2 is equal to 2 of tan theta minus 3 sine theta plus 1. And now I can simplify the bracket on the right side. So I get 2 tan theta minus 6 sine theta plus 2. Now I'm going to subtract tan theta from both sides. This means that tan theta will subtract from this 2 tan theta, so we get tan theta. So we now no longer have this tan theta on the left side. I'll also subtract 3 sine theta from both sides, so it will subtract to minus 6 sine theta. So minus 6 sine theta minus 3 sine theta will give us minus 9 sine theta. And then I'll subtract 2 from both sides. So 2 minus 2 gives us 0. So we are left with a 0 here on the left hand side. I would prefer to write it this way. So using the identity, tan theta is sine theta over cos theta, and it's minus 9 sine theta equal to 0. So I'll multiply both sides by all the terms by cos theta. So that's cos theta here times cos theta, and here times cos theta. So cos theta and this will cancel out. So we have sine theta left. And cos theta times minus 9 sine theta, we get minus 9 sine theta cos theta. And 0 times cos theta gives us 0. So I now have this equation here. I'll factor out sine theta. So I'll be left with 1 minus 9 cos theta. And it's all equal to 0. Now from here, it means that either sine theta is equal to 0 or 1 minus 9 cos theta is the one equal to 0. Now we know that sine theta is 0 for values of theta starting from 0 degrees itself, and also the next one is 180 degrees. But if you look at the range is from 0 to 90. So the only value of theta we're going to use is 0 degrees. So theta should come out as 0 degrees. Then for this one, we can write it as cos theta is equal to 1/9. And I'm going to use the calculator to find the value of theta, because we know that theta is arc cos of 1/9. So with the calculator, I'll type in shift cos 1/9. And the answer I get is 83.6 degrees to 1 decimal place. So theta is 83.6 degrees. Now from the quadrants, we know that cos theta has a positive value in the first quadrant. Since cos is positive and 9 is a positive number, so it has a positive value in the first quadrant as well as in this fourth quadrant. And the value for the first quadrant, if it is a theta, a value between 0 and 90, the second value will be out of range, which can be obtained as 360 minus theta. So the only value that theta can take is 83.6 for the range 0 to 90. So the answer here should simply be 83.6. So the two solutions for the range 0 to 90 are theta is equal to 0 degrees and 83.6. So that's the answer, that's the solution to this question here. Let's go on to question number 6. So let us look at question number 6. The coefficient of 1 over x in the expansion of 2x plus a over x squared all to the power of 5 is 720. So on A, find the possible values of the constant a. Now, here, we're going to use the formula for the general term of a binomial expansion. So we're saying for the expansion of a plus b to the power of n, the general term, the r plus 1th term, should be n choose r, a to the n minus r, b to the r. So this is what we're going to use for this question. So in this case, 2x is a, and b is represented by a over x squared, with the power n being equal to 5. So we can say the general term, ur plus 1 for this expansion, is 5 choose r, 2x to the power of n minus r, which will be 5 minus r, and b to the power of r, which is a over x squared to the power of r. So this is the general term for the binomial expansion of 2x plus a over x squared or the power of 5. So I can actually split this into coefficients and also x terms. And for the coefficients, I'll take 5 choose r, all the terms that are without x. So 5 choose r. Then here I'll take 2 to the power of 5 minus r. So that's 2 to the 5 minus r. And for here, I'll take a, which is the constant, raised to the power of r. So that's a to the power of r. And then for the x terms, I'll only have x here to the power of 5 minus r. And here I'll be having 1 over x squared to the power of r. So I'll simplify this expression for the x terms. So that'll be x to the power of 5 minus r. And 1 over x squared, that's x to the power of minus 2 raised to the power of r. So it'll be like this. So we can apply the laws of indices. 5 minus r will add to minus 2r. So it becomes 5 minus 3r. So this here is the general expression for the x terms of the binomial expansion of what we have here. But here the term of concern is the term in 1 over x. And 1 over x is actually x to the power of minus 1. So we can say we want the term where the general term is x to the power minus 1. And here we can equate the powers. So 5 minus 3r is equal to minus 1. So minus 3r is equal to minus 6. So r comes out by dividing both sides by minus 3, comes out as a 2. So the term here that we want is r being equal to 2. So since we now know that r is 2, and they say the coefficient of that term is 720, then I'm going to substitute r is equal to 2 into this and equate it to 720, since this gives us the coefficients. So the coefficient will be 5 choose 2, 2 to the power of 5 minus 2, so that will be 2 to the power of 3, and a to the power of r, which is 2, is equal to 720. So 5 choose 2 is 10, and 2 cubed is 8. So that's a squared is equal to 720. So basically we have 80a squared is equal to 720. So we can divide both sides by 80 to get a squared is equal to 9. And if we square root both sides, we get a coming out as plus or minus 3. So the two possible values of a are a is equal to plus 3 or a is equal to negative 3. And that's the answer for this question. We can scroll down to part B. Hence find the coefficient of 1 over x to the power 7 in the expansion. So here we're talking about the coefficient, and we obtained a general form for the coefficients, and we got it as this. So I'm going to take this general form for the coefficients. I'll take it down. And here it is. And we also have the general term for the x terms, which simplified to x to the 5 minus 3r. So I'll also take this. So this is the general term for the x terms. And it's x to the 5 minus 3r. So the x term here is 1 over x power 7. So we're saying x to the power of 5 minus 3r should be equal to x to the power of minus 7, which therefore means 5 minus 3r is equal to minus 7. Subtracting 5 from both sides, we get minus 3r is equal to minus 12. And dividing both sides by minus 3, we get r equal to 4. So the coefficient of 1 over x to the power 7 occurs when r is equal to 4. So for the coefficient now, for the answer, it will simply be 5 choose 4, 2 to the power of 5 minus 4 times a to the r. Remember, we got a as plus or minus 3. So that will be plus or minus 3 to the power of r, which is 4. So 5 choose 4 is 5. That's 5 times 2 times 3 to the power of 4 is 81. So 5 times 2, that's 10, and 10 times 81 is 810. So this is the solution. This is the coefficient of 1 over x power 7 in the expansion. That's the answer. Question 7. The diagram shows a sector A or B, which is part of a circle with center O and radius 6 centimeters, and with the angle A or B equal to 0.8 radians. The point C on OB is such that AC is perpendicular to OB. The arc CD is part of a circle with center O where D lies on OA. So all this information here is just describing the diagram here. So find the area of the shaded region. Now, in order for us to find the area of the shaded region, let's focus on this triangle, triangle AOC. So that's what we're going to focus on. And in order for us to find the shaded region, we are going to say the shaded area, so A shaded, is equal to area of triangle minus the area of the sector that's ODC. So if we can find the area of the triangle OAC, then subtract the area of the sector ODC, then we have the area of the shaded region. Now, in order for us to find the area of the triangle, we need to have at least two sides known. Already we know that OA has a length of 6 centimeters because it's part of the sector OAB, of which we've been told that OB is 6 centimeters. So that automatically translates to OA being equal to 6 centimeters. So we have that side. So the next side we need to find is OC. So we can use cos of 0.8 is equal to the adjacent side, which is OC, divided by the hypotenuse for this triangle, since it's a right angle triangle, the way, which is 6. So that means that OC is 6 cos 0.8. So shift mod, then radians, that's 4. So we are now in radians. And then I'll type in 6 cos 0.8. And I get 4.18. So the length of OC is 4.18. So now that I have the length of OC, I can now find the area of the triangle. So we are now saying for the shaded area, it's equal to the area of the triangle. The area of the triangle will be half times side times side. So it's half times the side, 6 centimeters, times the other side, which is 4.18. That's OC. And that's sine of the angle 0.8. And we subtract the area of the sector. Area of the sector, here, we know that for the area of a sector, we use the formula half r squared theta. So here we'll be saying half times the radius r for this sector is going to be like OC. That's like the radius for this sector. We had obtained OC as 4.18. So it's half times 4.18 squared times theta, which is 0.8. So this is the calculation for the shaded area. So I'll obviously need the calculator for this. So I'll type it in. And I'm getting it as 2.0066 going all the way. So to 3 significant figures, I'll have 2.01 for the area. And that's in square centimeters. And that's the answer for the shaded region. Question number 8. A woman's basic salary for her first year with a particular company is $30,000. And at the end of the year, she also gets a bonus of $600. On A, for her first year, express her bonus as a percentage of her basic salary. Okay, so for part A, the bonus is $600 and the basic salary is $30,000. So we multiply this by 100. So I'll simply cancel out the 2 zeros here and also the 2 zeros here. Okay. And then 3 into 6 gets in 2 times. So eventually we get 2% for our answer. So that's the working for part A. We go to part B. At the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by $100. Express the bonus she will be paid at the end of her 24th year as a percentage of the salary paid during that year. Okay, so let's start with the bonus. Initially, she was getting a bonus from the information we got from the question. She was getting a bonus of $600. Okay, so we're starting at $600. Then, according to the question, the bonus will increase by $100, which means that this is an AP, which is such that the common difference, D, is $100. So the $600 is the first term here. Alright, so to find how much she will get at the end of her 24th year, it's like we're looking for the 24th term. And we get that by saying A plus N minus 1D. I'm sure you know the formula for the nth term of an AP. That's A plus N minus 1D. So that's what I'll apply here. So the first term is 600 plus N minus 1, that's 24 minus 1, that's 23, times D. D is $100. Okay, so this is going to give us 600 plus 2,300, and this gives us 2,900. So this is the amount that she will be paid at the end of her 24th year. That's the bonus. Okay, let's talk about the basic salary. The basic salary, according to the question, it started out at 30,000. That's the information we have here, at 30,000. So that's $30,000. And then it is increasing at 3%. Okay, at the end of each year. So this means to me that it's a GP, a geometric progression. And since it's an increase of 3%, that will be 103% as the common ratio, which is 1.03. That's the common ratio for us here. So to find the amount she will receive at the end of her 24th year, we use the formula for the nth term for a GP. So that's going to be UN is equal to AR to the n minus 1. So in our case, this is going to be A, that's 30,000, multiplied by R, which is 1.03, to the power of n minus 1, which is 23. Okay, so I'm going to calculate this. So that's 30,000 multiplied by 1.03, and that's to the power of 23. And this gives us 59,207. So I'll just write it as 59,200. So to answer the question now, they say express the bonus she will be paid at the end of her 24th year. So that's the 2,900 as a percentage of the basic salary paid during that year. So that's over 59,200, and we multiply by 100. So this will give us 2,900 over 59,200 multiplied by 100. And this gives us 4.8986. So that's to three significant figures. This should give us 4.9. So that's 4.90%. And this is the answer for part B. Let's scroll down to the next question. And that's question number 9. Question number 9 goes, express 2x squared plus 12x plus 11 in the form 2 of x plus a squared plus b, where a and b are constants. So this is completing the square. So I'll write down 2x squared plus 12x plus 11. Okay, so since I want to complete the square, I'll focus on 2x squared plus 12x for now. So this is what I'm going to do. So I'll factor out 2. So that will be x squared plus 6x here. The 11 is here. Then I will open the bracket. Then x here plus half of the coefficient of x. So half of 6 is 3. Then squared. Then I subtract the 3 squared. So I've completed the square on this part, and that's plus 11. Then I'll continue simplifying. This means that I'll be getting 2 of x plus 3 squared minus 9 plus 11. So what I'm going to do right now, I'll skip a line. So this is 2. I'll multiply 2 times x plus 3 squared. So that's 2 of x plus 3 squared. Then 2 times minus 9, that's minus 18. then plus 11, that's already there. So here we are now saying minus 18 plus 11, that gives us minus 7. So finally the answer comes out as 2 bracket x plus 3 squared minus 7. So that's how we complete the square for 9 part A. Let's go on to part B of the question. On part B, the function f is defined by f of x is equal to 2x squared plus 12x plus 11 for x is less than or equal to minus 4. Find an expression for f inverse of x and state the domain of f inverse. So they want us here to find the inverse of the function. Now remember, for our f of x, when we completed the square, we got 2 of x plus 3 squared minus 7. So to get the inverse, I'll write it as y is equal to 2 of x plus 3 squared minus 7. And I'll make x the subject. So I'll add 7 to both sides. Becomes y plus 7 here. Then divide both sides by 2. So I have a 2 here. So now I have 2x plus 3 squared left on the right side. Then I will square root both sides. Okay. And if I do so, I'll be having plus or minus the square root of y plus 7 over 2 is equal to x plus 3. And finally, I'll subtract 3 from both sides. So minus 3 plus or minus the square root of y plus 7 over 2 is equal to x here remaining. Then I'll interchange the variables. So y is equal to minus 3 plus or minus the square root of x plus 7 over 2. So this gives us the inverse now. Inverse is minus 3 plus or minus the square root of x plus 7 all over 2. But now while we're here, I would want you to consider that for the function of f, x is less than or equal to minus 4. And from this, we can deduce that the range for the inverse function is also going to be less than minus 4. Okay, so that's a domain of function and a range of inverse type of relationship. So if the domain of the function is less than or equal to minus 4, it means the range of the function represented by f inverse of x should also be less than or equal to minus 4. So the only way that f inverse of x can have a value that is less than or equal to minus 4 is when we have minus here. So between minus 3 plus square root of x plus 7 over 2 and minus 3 minus square root of x plus 7 over 2, the only one where f inverse of x is going to be less than or equal to minus 4 is when we have f inverse of x taking the value minus 3 minus the square root of x plus 7 over 2. So this here is the one that we will settle for. So that's the inverse here. Now, they also say state the domain of f inverse of x. Now, you need to know that the domain of the inverse function is comparable to the range of the function. Now, what is the range of the function? The function here is a parabola. The minimum point of the parabola, if you look at the form of the completed square, should be minus 3 minus 7. We deduce that from the completed square format. Okay, And we're hearing that the domain of the function is x is less than or equal to -4. So this should be somewhere here. Since we have -3 here, -4 should be around here. So what we want now is to know the range, the y values for which the graph is going to be valid. So if x is going to be -4, if that's the x value, then what is the y value? Okay, so it means we can substitute -4 into the function. So if we substitute -4 into the function, you see how we have x plus 3, so that's -4 plus 3, that's -1. -1 squared, that's just going to give us 1. Then 2 times 1, that's 2. 2 minus 7 is -5. So -5 is the value here. So the range for values of x that are less than 4 is going to start from 5 going all the way up. So the range of f is actually y is greater than or equal to -5. And this automatically it becomes the form of the domain of f inverse. So here for the inverse, we are saying f inverse of x is equal to -3 minus square root of x plus 7 over 2. And the domain is going to be x is greater than or equal to -5. It takes the form of the range of the function. So this becomes our answer here for part B. For part C, it goes, the function g is defined by g of x is equal to 2x minus 3 for x is less than or equal to k. On part C, for the case where k is equal to -1, solve the equation f g of x is equal to 193. So here we want to find the composite function f of g of x, and it's equal to 193. Okay, so that means that we're saying is the function of g of x, that's 2x minus 3, should give us 193 here. Now f of 2x minus 3, which is g of x, we know that the function f of x, from what we have, is this. I'll use the completed format. So this is it here. So it means that in place of x, I'm going to put 2x minus 3. So it will now come out as 2 of, in place of x, I put 2x minus 3, and then plus 3, then squared, then minus 7 is equal to 193. So this is going to give me 2 of minus 3 plus 3, that's 0. 2x squared gives us 4x squared. Then minus 7 is equal to 193. I'm going to add 7 to both sides. Okay, so 193 plus 7, that's 200. Then 2 times 4x squared is 8x squared. Then dividing both sides by 8, I get x squared is equal to 200 divided by 8 is 25. Which means that if I square root both sides, I get x coming out as plus or minus of 5. But now that we have x being equal to plus or minus 5, according to the question, x should be less than or equal to k, and k is minus 1. So it means that x should be less than or equal to minus 1. So the value of x here that is less than minus 1 is minus 5. So therefore, I can conclude that x is equal to minus 5. So that's the solution to part C. Let's go on to part D. Part D goes, state the largest value of k possible for the composition fg to be defined. So here we're talking about f of g, which is f of g of x. Now you need to know that the function f has a restriction. If we go back up to part B, the restriction or the domain was that for f of x, x should be less than or equal to minus 4, which means whatever gets into f of x, whatever gets here, should be less than or equal to minus 4. So in our case here, it's f of g of x, which means that g of x, since it's now we are inputting g of x into f of x, should also be less than or equal to minus 4. But we've been given that g of x is 2x minus 3. So I'll say here 2x minus 3 is less than or equal to minus 4. That's 2x is less than or equal to, if we add plus 3 to both sides, we get minus 4 plus 3, which is minus 1. So x should be less than or equal to minus a half. So since, according to this part, x should be less than or equal to k, the maximum value that x should take is k. So in our case here, we can therefore deduce that k should have a maximum value of minus a half. So that's the value, that's the answer to part D. Let us now look at question number 10. It goes, the gradient of a curve at the point xy is given by dy by dx is equal to 2 of x plus 3 to the power of a half minus x. The curve has a stationary point at the point A14, where a is a positive constant. On a, find the value of a. So here, we've been given the gradient function dy by dx, and that's 2 of x plus 3 to the power of a half minus x. Now that we have the gradient function, we've also been told that the curve has a stationary point at the point A14. We know pretty well that at the stationary point, the derivative dy by dx should be equal to 0. So we are saying at the point A14, dy by dx should be equal to 0. So this means I'll write the gradient function 2 of x plus 3 to the power of a half minus x to be equal to 0. But since the x coordinate is a, this means that I can substitute a for x. So I'll now be having 2 of a plus 3 to the power of a half minus a is equal to 0. Adding a to both sides, we'll be having 2 of a plus 3 to the power of a half is equal to a. And it is from here that I'll square both sides. So I'm going to square this side and square the right side as well. If I do so, 2 squared should give us 4. A plus 3 to the power of a half squared means this 2 will cancel out with this 2, the powers. So I'll be left with a plus 3. And it's equal to a squared. Simplifying the brackets, I have 4a plus 12 is equal to a squared. And if I bring everything to one side by subtracting both sides, 4a and 12, eventually I'll be having the equation as a squared minus 4a minus 12 is equal to 0. I can now factorize this because it has now turned out to be a quadratic equation. So factorizing, I have a here, then the factors of minus 12, whose sum is minus 4, are minus 6 and plus 2. So this is how I factorize it. Which means either a minus 6 or a plus 2 should be equal to 0. But since according to the question, a should be a positive constant, we're going to use the factor a minus 6 to be equal to 0, which therefore is going to give us a being equal to 6. So 6 is the value of a at the stationary point. We can now scroll down to part B. Part B goes, determine the nature of the stationary point. Now, in order for you to determine the nature of a stationary point, you'd need to find the second derivative. The first derivative, we have dy by dx is equal to 2 of x plus 3 all to the power of a half minus x. So for the second derivative, we are going to differentiate the first derivative. So I have 2 here, then I'll bring down the half. Then the derivative of x plus 3 is just going to be 1. And then I'll write x plus 3 to the power of a half minus 1, which is minus a half. And that's minus the derivative of minus x, that's minus 1. 2 and 2 will cancel, which means that I'll only be left with x plus 3 to the power of minus a half minus 1. This can also be written as 1 over x plus 3 to the power of a half minus 1. Now, since from part A, we were told that A14 are the coordinates of the stationary point. To determine the nature of the stationary point, we have to substitute the value of A, which we got to be 6, into the second derivative. So I'm going to substitute the value of x. X is equal to A, which is 6. Then substituting 6 into this, we will now be getting the second derivative as 1 over 6 plus 3 to the power of a half minus 1. Now 6 plus 3 is 9. 9 to the power of a half is like square root of 9. So that's 3. So it's more like we have a third minus 1. And this gives us minus 2/3. And minus 2/3 is less than 0. And if the second derivative is less than 0 or negative, it means that it's a maximum. So it's a maximum point. That's the nature of the stationary point. So that's how we work out part B. Let's scroll down to part C. On part C, it says find the equation of the curve. Now, we've already been given from the question the gradient function. So the gradient function is what we have right here. So I'm going to take this and we're going to use the gradient function to work out the equation of the curve. So if we have dy by dx being equal to 2 of x plus 3 to the power of a half minus x, to get the equation of the curve, we will need to integrate both sides. If we integrate dy by dx, we are going to get y. If we integrate the right hand side, it means that here I'll be having 2 of x plus 3 to the power of a half plus 1, which is 3 over 2, divided by 3 over 2. And if I integrate minus x, I get minus x squared over 2. Now I'll continue simplifying. This means that I'll now be having y is equal to, and dividing 2 by 3 over 2, it means I'll now be having 4 over 3. And that's times x plus 3 to the power of 3 over 2, and that's minus x squared over 2 plus c. So we now need to find the value of the constant c. So we can use any point on the curve. And the point that we have is the turning point, A14. And since we'd obtained A as 6, so is the point 614. That's the turning point. So we use the point 614. So x can be 6 when y is 14. So I'll substitute this into this equation. It means that y is 14 is equal to 4 over 3 of 6 plus 3 to the power of 3 over 2 minus x squared, which is 6 squared over 2 plus c. So we can simplify. That's 14 is equal to 4 over 3. 6 plus 3 is 9. 9 to the power of 3 over 2 is like the square root of 9 cubed. Minus 6 squared is 36. So that's 36 over 2 plus c. This gives us 14 is equal to 4 over 3 of the square root of 9 is 3. 3 cubed is 27. So it's 4/3 of 27 minus 36 over 2 plus c. Let me just quickly simplify it. So 3 goes into 27 9 times. 9 times 4 is 36. And 2 into 36, that's 18. So we now be having 14 is equal to 36 minus 18 plus c, which is 14 is equal to 36 minus 18 is 18, then plus c, which therefore means that c is equal to 14 minus 18, and c is minus 4. So with c being minus 4, it therefore means that the equation of the curve should come out as y is equal to 4 over 3 of x plus 3 to the power of 3 over 2 minus x squared over 2 plus c, and c is minus 4, so minus 4. So this here becomes the solution, the equation of the curve as required by the question. Question number 11. Solve the equation 3 tan squared x minus 5 tan x minus 2 equal to 0 for values of x between 0 degrees and 180 degrees. So we have right here an equation which is in the form of a disguised quadratic equation. So what you can do is you can say let y be equal to tan x. And if you do that, it means your equation will now be 3y squared minus 5y minus 2 is equal to 0. So you can factorize this. So I'll get 3y plus 1 and y minus 2 from factorizing, which means that either 3y plus 1 is equal to 0 or y minus 2 is equal to 0. From here I get the value of y being equal to minus a third, and here we get the value of y being equal to 2, which therefore means that tan of x is equal to minus a third, or tan of x is equal to 2. So I'll use my calculator to type in arctan of a third. So this is what we get. We get 18.4 degrees. So we're getting a first value of x being 18.4 degrees. But then if we look at our quadrants, we know that tan is negative in this quadrant and in this quadrant. So x is going to have a value here and another value here. So the value of x in the third quadrant is going to be 180 minus theta, which is 180 minus 18.4. And the value of x in the fourth quadrant is going to be 360 minus theta. So the only value that's going to be in range is the value that we'll obtain in the second quadrant. So the true value of x here is 180 minus 18.4. So that's 161.6 degrees. So that's the first value of x here. Then if tan x is equal to 2, it means x is arctan of 2. So using our calculator, I'll type in arctan of 2. And this is giving me 63.4. So x is 63.4 degrees. And again, if we consider the quadrants, we know that tan is positive in the first quadrant and in the third quadrant. In the first quadrant, tan will have a value of theta between 0 and 90. And in the third quadrant, it will have a value of 180 plus theta. So the only value that is going to come in range is the value that's in the first quadrant between 0 degrees and 90 degrees. So 63.4 is the only x value that we're going to need. So we're saying here, our solution is x is equal to 161.6 degrees and 63.4 degrees. These are the two solutions. Let's scroll down to the next question. It goes, find the set of values of k for which the equation 3 tan squared x minus 5 tan x plus k has no solutions. So again, for this one, we will let y be equal to tan x, which means that we'll now be having 3y squared minus 5y plus k is equal to 0. Since we now have this quadratic, if this equation has no solution, this should mean that b squared minus 4ac is less than 0. So in our case, a is the coefficient of y squared, that's 3, b is minus 5, and c is k. So when we perform the discriminant, that will be minus 5 squared minus 4 of 3 of k, and that should be less than 0. So that's 25 minus 12k is less than 0, which means that if I subtract 25 from both sides, I have minus 12 is less than minus 25. And dividing by minus 12, I get k is greater than 25 over 12. Remember, dividing by a negative number reverses the sign. So the set of values of k for which the equation has no solution is values of k that are greater than 25 over 12. And that's the solution to part B. We can now go on to part C. On part C, the question goes, for the equation 3 tan squared x minus 5 tan x plus k equal to 0, state the value of k for which there are 3 solutions in the interval 0 to 180 degrees and find these solutions. So we have here the equation 3 tan squared x minus 5 tan x plus k is equal to 0. Now we already know that if tan x is equal to 0, then for the range 0 to 180, x is going to take 2 values, which is 0 degrees and 180 degrees. So tan x is 0 when x takes these values 0 degrees and 180 degrees and more values, but for the range 0 and 180, x has 0 degrees and 180 degrees. So if I can find a way to express this equation in such a way that I'll eventually get tan x is equal to 0, then my job is half done because already I have 2 values. Remember, we want to state the value of k for which there are 3 solutions. So my job here is half done if I have 2 values already. So the only way that can happen is when we set k to be 0. And this means that I'll now be having 3 tan squared x minus 5 tan x plus k, which is 0, is equal to 0. And I can now factor out tan x and have 3 tan x minus 5 is equal to 0, which therefore means either tan x is equal to 0, which is a favorable position for us because we will get 2 of the solutions for the range 0 to 180, and also 3 tan x minus 5 is equal to 0. So here it means tan x should be equal to 5 over 3 and x should be arctan of 5 over 3. So I'll use my calculator to type this in. So that's arctan of 5 over 3. And this gives me 59 degrees. So we have the value of x as 59.0 degrees. Now we're not going to find other values of x because they'll simply be out of range. So the only values that we'll now be having here will be x is equal to, from tan x we'll be having 0 degrees and 180 degrees. And from here the value will be 59 degrees, 59.0. So these are the 3 values, 3 solutions of x, and the value of k is set to 0. So that's the solution to part C. Question 12. A diameter of a circle C1 has endpoints at -3, -5, and 7, 3. Zone A. Find an equation of the circle C1. So this is the question that we have here. So what we've been taught here is that we have a circle, and the circle has a diameter with endpoints at -3 and -5 and 7, 3. So we want to find the equation of this circle here given these 2 endpoints of the diameter. So with these 2 points, we can actually find the coordinates of the center, which is the midpoint between the 2 points. So we're saying the center is equal to the midpoint, and to get the midpoint we add -3 plus 7 divided by 2, then -5 plus 3, and we divide that by 2. And this is going to give us -3 plus 7, that's 4, and 4 divided by 2 is 2. -5 plus 3 is -2 divided by 2, that gives us -1. So these are the coordinates of the center. And now, since we now have the coordinates of the center, we can also work out the radius. So we can use either of the 2 points. So I'll use the point -3, -5, and the coordinates of the center 2, -1 to work out the length of the line. So r squared is equal to -3 minus 2 squared plus -5 minus -1. So it becomes +1 squared. This gives us -3 minus 2, that's -5, and squared, that gives us 25, plus -5 plus 1 is -4, and squared, that gives us 16. So adding the 2 gives us 41. So the equation of the circle should come out as x minus the x coordinate, that's 2 squared, plus y minus -1 becomes y plus 1 squared, and it's equal to r squared, which we got to be 41. So this is the equation of the circle C1. Let's scroll down to part B. the circle C1 is translated by 8, 4 to the circle C2 as shown in the diagram. So in part B, find an equation of the circle C2. So here we have a translation. We have the center of C1, which we got to be 2 minus 1, and all the points on circle C1, including the center, are going to be translated to C2. So the center will have a new point here. And the transformation is a translation, which is a movement in a straight line by 8 across and 4 going up. So to get the new coordinates of the center, which are the coordinates of the center of C2, we simply add 2 minus 1 to 8, 4, which is the translation vector. So 2 plus 8 is 10, and minus 1 plus 4, that's 3. So we now know that the coordinates of the center of C2 are 10 and 3. Now that we have the coordinates of the center, we can write down the equation of the circle C2, since the translation will not affect the radius of the circle. So we will now be having x minus 10 squared plus y minus 3 squared is equal to r squared. And you know we got r squared for C1 to be 41. So we will use the same value for r squared here. So that's equal to 41. So this is the equation of the circle C2. Let's go to part C of the question. The two circles intersect at points R and S. Show that the equation of the line RS is y is equal to minus 2x plus 13. So here we have the 2 points R and S, and they want us to find the equation of the line RS. Since the points R and S are the points of intersection of circle C1 and circle C2, we can actually do simultaneous equations with C1 and C2 to see if we can get the equation of RS. So let's try to do that. So I'll take the equation of C1, and here it is. And I'll put it here. And also the equation of C2, which we got here. So we now have the two equations. So this is C1 and this is C2. So to solve them simultaneously, I'm sure you can see that they all equate to 41. So we can actually say x minus 2 squared plus y plus 1 squared is equal to x minus 10 squared plus y minus 3 squared. So I'm now going to expand. So x squared minus 4x plus 4 is what we get from this one. Plus, expanding this, we get y squared plus 2y plus 1. It's equal to, here we will be having expanding x minus 10 squared, that's x squared minus 20x plus 100. And then expanding y minus 3 squared, that's y squared minus 6y plus 9. So we now have this equation here. So I'll eliminate x squared, subtracting it from both sides, and y squared again, subtracting it from both sides. I'll add the numbers 4 and 1, and they will give me 5. So I have minus 4x plus 2y plus 5 on the left side. And on the right side, I'm going to add 100 plus 9 to get 109. and I have minus 20x plus minus 6y. So that's minus 6y, and that's plus 109. I'm going to take everything to one side. So I want to take 2y on the left side, then add 6y to both sides. So I have 6y here, and I'll take the minus 4 that we already have, minus 4x, then add 20 to both sides. So that will be plus 20x. I have the 5 already on the left side, and I'll subtract 109 from both sides. So that will be minus 109. So it means on the right side I have 0. So 2y plus 6y is 8y. So minus 4x plus 20x gives me 16x. And that's plus 5 minus 109, which is minus 104. And that's equal to 0. So I'm going to divide all the terms by 8. And I'll cancel. So here I'll be having y plus 8 into 16 goes in 2 times. So that's 2x. Then 8 into minus 104, that's minus 13, is equal to 0. So I can actually express this equation with y subject. So it's y is equal to 2 going to the other side, that's minus 2x, and minus 13 add into both sides, that becomes plus 13. And we thus have the equation of the line RS as required by the question. Let's now scroll down to part D. It goes, hence show that the x coordinates of R and S satisfy the equation 5x squared minus 60x plus 159 equal to 0. So for this one, I'm going to take one of the equations of the circle. So let me take C2. And here it is. And I'll also take the equation of the line RS. So here it is. So to come out with this equation here, I'm going to substitute for y. I'm going to put minus 2x plus 13 into this equation. So that means that I'll be having x minus 10 squared plus y minus 3. So in place of y, I'll put minus 2x plus 13. So that's minus 2x plus 13 minus 3, which is here, all squared, is equal to 41. So that's x minus 10 squared plus minus 2x, and here 13 minus 3, that's 10 squared is equal to 41. So I'll expand the brackets. So x minus 10 squared is x squared minus 20x plus 100. And that's plus, expanding this one, minus 2 squared, that'll be 4x squared. Then minus 2x times 10 multiplied by 2, that'll give us minus 40x. Then 10 squared, that's 100, is equal to 41. So I'll add the like terms. So x squared plus 4x squared will give us 5x squared. And minus 20x minus 40x should give us minus 60x. Then 100 plus 100 is 200. And if we subtract 41 from 200, so that we have 0 on the right side, we are left with 159. And that's equal to 0. So what we now have is the same equation that they want us to find. And that's how we do it for part D. And that concludes the paper.